Hi, in this short presentation I want to go over the example done in the previous part in the video lecture to show you how the general Fourier series approximates a function. So this time again we're dealing with a function which is neither odd nor even, and let me run this first command here. The function that I used here, so actually if you look at the piecewise definition here, I took the function from the previous from the example that I ran before, except that I extended it to another period. So the example in question was f of x equals 0 between minus pi and 0, the first branch here, and x between 0 and pi. So if you look at the graph between minus pi and pi, this is what we used in the example before. Now remember, because the Fourier series involves sine and cosine functions, each of them is periodic with period 2 pi over this. I mean, if we start with just cosine nx or sine of nx between minus pi and pi. So I just basically repeated the graph over the next period to the right. You could of course extend the same shape to other periods on the left or on the right. And this is the Fourier series which is we derived. The first portion here is the Fourier cosine series for the even part of the function, and the remaining part of the Fourier sine series for the odd part, obviously. So let's actually run just 4 terms of this series, and let's plot it. And you kind of already probably see that it approximates already decently well, I guess, the original function. Let's see if I can drop it here over the graph. And let's do one more run, this time with more terms, like let's say 20 of them. I'm going to erase this. Let me actually get rid of this as well. And that's the graph, which is obviously a better approximation. All right, so we're going to go over more examples in the next lecture. The thing I want to mention before closing this short presentation is that we will see, in fact, that the Fourier sine series by itself and the Fourier cosine series are just basically particular cases of this general Fourier series. If you were to use the formula for a general Fourier series to find the representation for an even function, the formula will simply lead you to 0 coefficients for the sine part. So in a way, the formulas for the cosine and sine series themselves are essentially particular cases of the more general Fourier series. But we'll deal with this type of examples and discussions in the next lecture. And so that's it for this presentation.